All right, hello everyone. Week 1, lesson 2. We're going to continue on with factoring. We're going to factor some polynomials of higher order, higher degree. We're going to do that by hand and on our calculators. I hope you're all up to the physical challenge. Let's get started. All right, so we're going to do, again, some factoring of higher order polynomials today. We're first going to do some where we factor completely by hand. Then we're going to do one where we factor with the aid of our graphing calculator, and then we're going to do a couple where we will start off with our graphing calculator and then continue on to factor completely by hand. So our first two, we're going to factor these completely by hand. All right, so again, our directions are to factor completely, and we need to do that by hand. Whenever we need to factor, the first thing we should do is try to look and see if there is a greatest common factor, a GCF, that you can factor out of your polynomial. And with this one, there's not a number that all of these terms are divisible by, but every term does have at least an x with it. So we can factor out a GCF of x. All right, which leaves us with a quadratic trinomial in the form of ax squared plus bx plus c inside. That quadratic trinomial, we need to see if we can factor a little bit more. So we're going to go with that AC method where we start by multiplying our a times c. 3 times negative 20 gets us to negative 60. And then we need to look for factors of negative 60 that are going to add to that middle number there, the b, which is 7. Let's see if you can find a set of factors of negative 60 that will add to 7. 1 and 60, 2 and 30, 60, 60. We'd have to do, what, 3 and 20, 4 and 15, 5 and 12, 6 and 10. And then it's just going to start repeating. Looks like right here, if we make one of those positive, one of those negative, we should get to a positive 7. So looks like positive 12, negative 5 gives us negative 60. 12 plus a negative 5 does get us a positive 7. All right, we need a little bit of room, so I'm going to get rid of this. All right, and then we're going to keep the first piece. Let's bring down our x, let's not forget about that. But keep that, actually, you know what, we'll leave x off for right now. Won't forget to bring it back at the end. So we have that 3x squared plus 7x minus 20. We're keeping the first piece and keeping the last piece, but we're unsimplifying that middle term. Right, we're unsimplifying that middle term. So that 7x has been unsimplified, has been split up into 12x minus 5x. So now we're going to take a look at the first two pieces. Factor a GCF out of the first two pieces, and that's going to be a 3x. And factor a GCF out of the next two pieces. That's going to be a negative 5. And when we take a look there, our two sets of parentheses are the same, both x plus 4. So we can take that set of parentheses, bring it all the way to the front, and then inside your next set of parentheses is the 3x and the minus 5. All right, one last thing, we want to bring that x down that we had from before. And we have factored that then completely. All right, so our next one, again, our directions are to factor completely and to factor by hand. This one is x is raised to the fourth power, fourth degree, a quartic polynomial. We always want to take a look again, see if there is a GCF that you can factor out. And it looks like we do have a GCF of x squared that we can factor out. Leaving us with x squared minus 81. That x squared minus 81, it's quadratic, and that also can be factored. It is our difference of squares pattern. If you don't recognize the difference of squares pattern, you could think about it as x squared plus 0x minus 81. Are there factors of negative 81 that add to 0? Yep, that's going to be plus and minus 9. So that x squared stayed outside. And then x plus 9 and x minus 9 was what that difference of squares piece factored into. All right. So we were able to do these higher order polynomials by factoring out a GCF and then factoring the resulting quadratic polynomial. Okay, so this one here, it says our directions are to factor with our graphing calculator. And if we looked at this, there's not a GCF that we could factor out right now. There's no methods that we've talked about today that we could use to factor this by hand. So here we go with our calculator. All right, so we have our calculator. Let's type in our polynomial, x cubed. And then we had 4 plus 4x squared. Minus 27x minus 90. All right, make sure we typed it in correctly. X cubed plus 4x squared minus 27x minus 90. We'll start with our regular window, zoom standard, option 6. And when we take a look at that graph, all right, let's see here. We need to find our x-intercepts, the zeros of our polynomial. Let's see, -1, -2, -3, -4, -5, -6, and then also 1, 2, 3, 4, and 5. This was cubic, and we do have then 3 zeros, so that's all of them. Yes, we can see them right there from the graph. If you wanted to, you could calculate them, or you could even take a look at your table. It looked like -6. And then let's have our table go up by 1. And then when we take a look there inside our table, when x is -6, yes, our y is 0. And when x is -3, again, our y is 0. And when x, let's scroll down 1. When x is 5, our y is 0. So we do have all of the zeros, all of the x-intercepts. So we're ready to factor. All right, if we had zoomed out a little bit, we would have seen that our graph would have looked like this, but something like this. But again, we have our zeros, our x-intercepts. Those are the important pieces for us that we're trying to factor. So whenever we need to take our zeros and write them as factors, if these are our zeros, x is equal to -6 is a 0. If you want to take a look at that as a factor, you would just move the 6 to the other side. So it would look like x plus 6. So that means to write our zeros as factors, our 0 is -6 as a factor, it's +6. So to write a 0 as a factor, it is always x minus the 0, x minus the 0. So up here, all right, x minus the 0, x minus -6, x minus -3, and then x minus 5. We can do one more, simplify, becomes x plus 6, x plus 3, and x minus 5. All right, so we factored that with the aid of our graphing calculator. This is one that we actually, we would not be able to do that by traditional methods by hand. We would have to do some other things that we're just not going to get into today, maybe in the future. But for right now, no, that's what we're going to do. All right, so our directions again are to factor completely, and it says using your calculator and methods by hand. With that very first one there, 10x cubed, if we took a look at that, there's not a GCF that we could factor out of everything. Again, no methods that we've talked about by hand that would help us, so we're going to start with our calculator. So let's go ahead and graph our polynomial. It was 10 x cubed plus 53 x squared plus 14x minus 5, 10x cubed plus 53x squared plus 14x minus 5. Zoom standard was our previous window, and that should work for us here. Let's take a look at our graph. And when we take a look at that graph, I can only see it looks like one easy crossing point there at -1, -2, -3, -4, -5. I'm not sure about those ones right there. So we're going to have to go back to the board and do some work by hand. So -5 was a 0. All right, so we had an x-intercept, a 0 at -5. So we're going to have to use synthetic division to divide out that 0 and then see if the resulting polynomial is factorable. All right, so when we do our synthetic division, we haven't done that in a while, you put the 0 in the little box. You bring down all of your coefficients, making sure every degree is represented. 10, 53, 14, and -5. Cubic, quadratic, linear, and constant. All right, you bring down the 10, multiply the 10 by -5, -50, add down, +3, 3 times -5, -15, 14 plus -15, -1, -1 times -5 is a +5, add down, and that's our remainder. So we read our graph correctly when we thought there was a 0 at -5 because we ended up with a remainder of 0. So let's see here, what is the resulting polynomial after we did that division? It was cubic. We divided out one factor, one linear factor, one linear 0. So that means this is quadratic. And then let's see if this quadratic is then factorable. Whoops, I missed my 10. Are there factors of -10 that add to +3? So we're going back to our a times c. 10 times -1 equals -10. Are there factors of -10 that add to +3? I believe there are. 5 and 2, if we make the 5 positive and the 2 negative. All right, so we'll keep the first piece. We'll keep the last piece, but we'll unsimplify the middle piece. Then we're going to go and factor a GCF out of the first two pieces, 5x, and a GCF out of the last two pieces. Okay. Those parentheses are the same. The parentheses are the same. So the set of parentheses can jump all the way out to the front. Can we write down low? Nope, we're going to need to continue on over here. So that 2x plus 1 comes out. And then inside the other parentheses were the 5x and the -1. Okay. But let's see here, that's quadratic, but the original was cubic. All right, the original was cubic, so we need to have 3 factors. All right, so our original, let's see here, we could, one factor, 2 factors, but then that last one is going to come from that x minus negative 5. All right, that x minus negative 5. And then again, that minus and negative is going to turn into a positive. And there we go. All right, so here we go again, same directions. This time x cubed plus 4x squared minus 13x minus 52. Again, no GCF. Right now, no methods that we've talked about today that we can do this by hand. So let's start with our calculator. All right, so let's go ahead and graph this one. I already have it typed in. Let's start off with that regular window of zoom standard. Take a look at our graph. Let's see here. That number I can't tell easily, and I'm not really sure what's happening over here. So let's maybe change our window a little bit. That's around what? -1, -2, -3, -4, -5. So window, how about let's go -6 for our x min and -2 for our x max. And then let's have those y's go, can't really tell it was happening really close to that x-axis, so let's go -1 to 1 for our y min, y max. Take a look at that graph. Okay, this was -6, -5, and then there is -4. So it looks like we have a 0 at -4. We could double check that with our table. If we just started at -4. And then up there, the y is 0. So we're good. We've got 1, 0. The others we'll find by hand. All right, so we had a 0 at -4. So we're going to use synthetic division again to divide that out. If you don't want to use synthetic division, you can use long division, but I really don't think anyone preferred long division to synthetic division. So we put our 0 in our little box. We bring down every degree, making sure every degree is represented. Cubic, 3, 2, 1, and 0 constant. So every degree is represented. We don't need any placeholders. All right, we bring down our 1, multiply by our 0, which was -4, 0. Multiply by our 0 again, 0. Multiply by our 0, gives us a positive 52, and 0. So again, we were correct reading the graph and using our table since we got a remainder of 0. -4 was truly a 0 of the polynomial. So what are we left with? Our resulting polynomial. It was cubic. We divided out one factor, so we knocked it down a degree. It is now quadratic. So we've got x squared minus 13. We could factor this by difference of squares. 13 is not a perfect square, but we could go with x plus square root of 13, x minus square root of 13. All right, we wanted to factor the whole thing. We know we should have 3 factors: x plus square root of 13, x minus square root of 13, and then our last one is going to come from that first 0 that we found with our calculator. Remember, it was always x minus the 0. And then you can just do, take that minus a negative and change it into addition. All right, I believe we've got one more. All right, last one. We're going to do that bottom one, x to the 4th minus 7x cubed plus 10x squared plus 14x minus 24. Again, I do not see a GCF that we could factor out of the whole thing, and we've not talked about any other methods that we could do this completely by hand today. So let's start with our calculator and go from there. All right, so we have it typed in here, and it's 4th degree, so there should be 4 zeros. Let's take a look at the graph. Moving back to our zoom standard window, and I do see it crossing the x-axis 1, 2, 3, 4 times. I can't really tell what this one is over here. I'm not really sure what this one is over here either, but over here it looks like, what, 1, 2, looks like 3 and 4. It looks like we have zeros at 3 and 4. We can double check that with our table. Let's just start, actually let's start at 0 and go up by 1, maybe make it a little bit easier to see there. Oops, I wanted table. There we go. All right, so when x was 3 and 4, all right, we have a 0 when x is 3. We have a 0 when x is 4. All right, so we can take those two factors and divide them out. So we said we had two zeros that we saw from our graph, so we're going to have to divide them out one at a time. I'm just going to start with the 3. Bring down the 1, multiply by the 0, multiply by the 0, add down, multiply by the 0, add down, multiply by the 0. So we read the graph correctly. All right, we read the graph correctly if we got a remainder of 0. So now we're going to continue on. Bring these numbers down and divide the next 0 out. The next 0 was 4. Bring the 1 down, multiply by the 0, 0, times 4 is 0, negative 2, negative 8, and 0. So again, we read the graph correctly if we ended up with the remainder of 0. So let's see, it was 4th degree originally, and we divided out 2 zeros, so that takes us down to a quadratic. So the resulting polynomial is quadratic. All right, so x squared minus 2, quadratic. We could factor that with difference of squares if we did x plus square root of 2 and x minus square root of 2. All right, so overall, if we wanted to factor this completely, then again, we had 4 factors. We always said it was x, let's see, we had x plus radical 2, x minus radical 2, and then it was always x minus the 0. So that was our last problem for today. There is a Google form that has a couple questions for you to do on multiple choice. Refer to these if you need to. Have fun, and hopefully this means that factoring will no longer be a physical challenge for you.